So parabolas are something you have seen a lot of whenever they are solved for y. You probably have not seen sideways parabolas that are solved for x. Have you guys seen sideways parabolas before? Gabby says yes. Okay. You haven't done it in class though, right? Just the art project thing. If you switch your x's and y's, it is going to make a sideways parabola because these are like inverses of each other, and it has reflected over the line y equals x. So the three types of forms that we typically see parabolas given in, you might see them in expanded form, sometimes also called standard form here, where you just have x squared plus ax squared plus bx plus c. This is what you need if you're doing quadratic formula. We've seen that a lot. You do a lot with factoring, so you've seen these given as factored form, and then you should have seen, at least when it's solved for y, vertex form. Vertex form, we haven't done vertex form, but we have done a lot of stuff that helps us know what vertex form is, because what does this minus h do to the graph right here? Moves it to the right h, right? And then the plus k moves it up or down k, right? Up, in this case, if k is a positive number. So that is going to give you your vertex, and then this a is either going to stretch or shrink that graph. Yeah, and the sign of that a will flip. So like this one, it would have a negative a because it would be flipped upside down. So vertex form is what we're going to be focusing on for what we're doing now. When we switch everything x's and y's, most of the same stuff still applies, but it's all sideways. It's all backwards. So this can be just a little bit confusing. So let's look at different things for our parabolas. So a equation that is solved for y is going to open up or down. That a right there tells you whether or not it opens up or down. If you have a positive a, it's going to be up. If it's negative a, it's going to be down. Left and right is going to be whenever you have x equals something where your y is squared. And so in this case, did I put this on here later? Yeah, I did. Okay. So in this case, if you're opening, it's going to open to the right if a is greater than 0. So a positive is going to be one that opens to the right. A negative is going to be one that opens to the left for these. So do I have this on here? Yes. Okay. A parabola does have a focus and a directrix. So we're going to talk about kind of what those are here in a minute. But this P equals 1 over 4a. That is your focal length. Similar to our ellipses where we did c squared equals a squared minus absolute value of a squared minus b squared. We have this formula here to find our focus of our parabola. This is pretty straightforward. Vertex is h. Notice the k is positive here and still positive here, because this moves it to the right h and then up k. So you change the sign of this value, but you do not change the sign here because it's not inside of the parentheses. The focus, whenever you're looking at a focus for a parabola, it's going to be on the inside. This right here, that would be the focus. And then the directrix is going to be this line on the outside. That these will both be the same distance away from the vertex. And I'll show you in a minute exactly like what that is. And so your axis of symmetry is just going to be the line where this folds in half. If this is your equation, then it would be vertical. Over here, it would be horizontal. And then whenever you look at the ones that open left and right, everything's sort of backwards for this. So same stuff, but a little bit backwards. So let's look at what a parabola is, which hopefully, well, let's see if this still works. I didn't test it. So I have made the this Desmos graph that hopefully is going to come up whenever I put this in. Yes. So the definition of a parabola is the set of points equidistant from a point, that should say and, a line. That point is called the focus, the line is called the directrix. So if you look at this Desmos graph here, this point right here is our focus, and then we have this line that is the same distance away from our vertex that's called the directrix. So you can see right here we got our point, our focus is at 2, 3, the vertex is at 2, 2, the directrix is down here at 1, so they're 1 unit away from each other. So the parabola is going to be all of the points that are the same distance away from this focus and this directrix. So you can see these two little dotted lines right here look like they're about the same length. They should be the same length. So as I go along the parabola, you can see that the length of those dotted lines change, but they still look like they're equal to each other. So all of these points are the same distance away from that focus as they are the line right here. So that is your definition of a parabola. You're the same distance away from that focus as you are the line. All right. So the focus and the directrix are values that they want us to be able to find. Similar to what I showed you guys with the ellipses, there may be times where you would need to know those two values so you could make a parabola that fits certain parameters that you're looking for these. So let's go back over here. All right, so let's look at finding vertex, focus, directrix, and axis of symmetry. And I tried to do more of the sideways parabolas in the notes because I feel like those are the ones that we're probably going to need some more help with. So for these, I am not going to make you sketch a proper graph, but I find that it really helps to draw a rough graph whenever you're finding these values. So the first thing you're going to be looking for these is the vertex. And so everything is backwards here. So when I'm looking for my vertex, I need to look right here inside of the parentheses. I'm going to use the opposite sign because this is inside of the parentheses. I will get a 4. Is that my x or my y coordinate? It is y because it's in the parentheses with the y. So that goes here. Okay. So then my x coordinate would just be positive 3. So whatever's inside of the parentheses is going to go opposite direction, but whatever is on the outside stays like it is. Okay. So our vertex is at 3, 4. This is a sideways parabola because it's x equals, this number right here is positive. Will this one open to the right side or to the left side? To the right. Since 2 is greater than 0, since it's positive, we open to the right. So we've got a parabola. I'm going to just do like a really rough sketch of a parabola here. And that vertex right there is at 3, 4. All right. If you graph it and look at which direction it opens, that is going to help you find all of the rest of these parts. So the formula P equals 1 over 4A gives you your focal length for the parabola. So for this particular problem, your A is 2, so P equals 1 over 4 times 2, so P is 1/8. All right, so that means that your focus is going to be here on the inside of the parabola, and it is going to be 1/8 unit to the right. And then you're going to have a directrix, which is going to be this line over here, and it is going to be 1/8 of a unit to the left. it might be helpful, instead of doing 1/8, to do point, is it 125, I believe, for 1/8, I think that's right. Decimals will be a little easier to deal with as far as doing this and not having to do all the fractions. So, let's start with focus. If I'm at 3/4 and I move to the right, 0.125 or 1/8, which coordinate's going to change? It's going to be the 3. The x coordinate changes because you're moving to the right or the left, and the x coordinate determines how far right or left you go. So you're going to the right, which is positive, so you're going to get 3.125 for there. The directrix for this is this vertical line. Vertical lines, are they x equals or y equals? X equals. So this is an x equals line. My x coordinate here was 3. I went to the left, 0.125. So what will I get for my x coordinate here at this line? 2.875. So my directrix is going to be x equals 2.875. We're just taking 3 and subtracting that 0.125. Okay, so we've got the vertex, the focus, the directrix. The last thing that you need is your axis of symmetry here. Hello? Yeah. You gotta be kidding me. Oh my. Has it ever been that bad before? Yeah. Mine's definitely never looks like that. Well, yeah, if you get the one, oh my. You're welcome. Bye. Okay. Alright, so, for this, we need axis of symmetry. I'll just call it AOS. That is a horizontal line. Horizontal lines are x equals or y equals. It'll be y equals. And you're going to use your y coordinate here, which is 4. So y equals 4. You can use formulas for this instead, where you have like positives and negatives. But to me, formulas are sometimes difficult to remember long term. And if you just think of sketching this out in which direction you would go, I think that is most of the time easier for students to remember long term. Okay, questions here? Now that one was already in vertex form for us. This next one is not in vertex form. Okay, now I could, if I wanted to, this is a parabola. Which direction is it going to open? Up. This one's going to be up because it's a y equals, so that tells us up or down, and then it has a positive x squared. So this one is one that opens up. If you want to, you could go ahead and draw that out. So we are still going to complete the square for these. It's going to be a little bit different than it is for circles and ellipses and hyperbolas because we only have one variable that is squared. So like we did for the others, we're going to factor out a 2. We'll have x squared minus 4x. I'm going to put a plus blank, and I'm going to leave this 5 out over here. I'm not going to do anything with the 5. I'm going to put it on the other outside of the parentheses. Now for the circles and ellipses, we would have taken that that 5 and moved it over to the other side and made it negative. You could do that here if you would like. But because we want this to end up being just solved for y, it's going to be a little bit easier if we leave it right here. So where I have a plus blank here, I could put a plus blank on the other side if I wanted. Because if I add something to one side, I must add it to the other side as well. But there's another way you can deal with that. If I add something right here, I could also subtract that same value from the same side, right? If I add 2 to a side and then subtract 2 from that same side, that also cancels each other out and is not going to change the value of my function. So for these problems, it's going to be a little bit easier to do this where we add here and then subtract that value over here. So we will complete the square like we have been doing. So we got -2. We'll go here, divide that number by 2. Our square, we will square that and get 4 right here. What number should I subtract from the end? 8. Good, because that 2 right there would be distributed to that 4. So you still have to, just like we did with the others, still have to multiply this by that number right there. And so 5 minus 8 is going to give us -3. And that'll put this in vertex form for us. So, Liam, what is the vertex of this parabola? -2, -3. All right, so our vertex there is going to be 2, -3. Opposite sign for our x-coordinate, keep the same sign for that y-coordinate because it's not inside the parentheses. Okay, we're actually going to get the same p-value here. It's 1/4a. The a's. Hello? Hey. I have my stuff. Okay, you're welcome. Okay, so we're going to get 1/8 again, or 0.125. I didn't really mean for it to be the same, but it is on this one. So for the focus, in this case, the focus is going to be on the inside of the parabola. We're going up 0.125. And the directrix is going to be on the outside. We're going to go down 0.125. So for this problem, because we're going up or down, which variable is going to change? The x-coordinate or the y-coordinate? Y. So my focus, the x-coordinate will stay the same. It's still 2. And then I've got -3, and I need to add 0.125, which is going to give me -2.875. There. I realize that seems like the wrong direction, but remember we're in negatives here, so that's actually higher than -3. Our directrix this time is horizontal, it's not vertical. So horizontal lines, x equals or y equals? Y equals. It's backwards from the axes. So it's y equals. Our y-coordinate here at the vertex was -3. We went down 0.125. So we're going to do -3 minus 0.125, and we'll get -3.125. And then axis of symmetry, that's going to be this vertical line right here. So axis of symmetry is going to be x equals, since it's vertical, and it's just going to be the x-coordinate, which is 2. Questions? All right, let's do another one that's sideways. So for example 3, we got x equals y squared minus 12y plus 4. Is this going to open up, down, left, or right? Gabby says to the right. She is correct. We know it's left or right because it's x equals, and the number in front of our y squared is positive there, so that's going to tell us to the right. Negative direction will be left for this. So much like the last problem, we are going to complete the square, but only for our y's this time. And for this one, you don't have anything to factor out because there's no number in front of that y squared. So, we're going to have y minus 6 squared. That's half of our 12. 6 squared is 36. We must subtract that 36 over here. So we're going to get minus 32. So, Connor, what's our vertex on this? Almost. It's going to be negative 32. 6. Because that negative 32 is not inside of the parentheses, you keep that negative sign with it. But the y is going to be a positive 6 because it is inside the parentheses. So this point right here is at negative 32, 6. Everybody okay here? So we got to find that p value. It is 1 over 4a. What is the a? There's no number here, so it is 1. So we got 1/4 or 0.25 if we just want to deal with decimals. So focus is on the inside of the parabola. Directrix is on the outside. And you're going to the right 0.25 and to the left 0.25 to find those. So, focus would be, we're starting from the vertex, we're going to the right 0.25. Which variable is that going to change? It's going to be our x, so we'll have, we're going to add 0.25, so negative 32 plus 0.25 is going to be negative 31.75. The y coordinate will stay the same. Directrix is to the left. It's going to be x equals, and you're going to have negative 32 minus 0.25, so you'll get negative 32.25 for that. And then the axis of symmetry is that horizontal line. And Smith, what's the equation of our axis of symmetry going to be?
Y equals negative 32?
No. It's going to be y equals. What is, it goes through the vertex. What's the y coordinate of the vertex? 6. So y equals 6. Yeah.
Kind of zoned out.
Okay. Questions? Okay, let's look. Hold on. There's one, did I add in a problem? Okay, let's look at this. I think I added this and I think this is what I need. Alright. Is this up, down, left, or right? Or can you tell right now? Which variable should this be solved for? X or Y? The Y is squared, right? So we need to solve this for x. So here is what I'm going to do. I'm going to distribute right here. So that's y squared equals negative 4x plus 12. And then in this case, I don't have just a plain y, right? I'm just going to solve this for x. I'm not going to have to put this into vertex form. I'm not going to have to complete the square because there is no plain y there with it. So I'm just going to subtract 12. So y squared minus 12 equals negative 4x. And then I'm going to divide everything by negative 4. So that's going to be negative 1/4 y squared plus 3. I'm going to put the x over here. X equals. You don't have to complete the square on this because you don't have a y term. So you could also think of this if you want, if it helps a little bit, to think of this as y minus 0 squared plus 3. We would never write it like that because that 0 is unnecessary, but that's what we think of it as. Okay, questions so far? Yes. Alright. Does this open up, down, left, or right? X equals means left or right. What do you think? Not down. It would be down if it was y equals. Like if this was y equals something, it would be down for that. But this one's x equals, which is going to open left or right. And so the negative direction for left or right would be left. So this one's going to open to the left. So your parabola will look like this. Troy, what's the vertex going to be? So right here, good. 3, 0 is your vertex. Now in this case, that P is 1 over 4 times A, and your A, I'm going to ignore the negative. If you're really relying on formulas, you need to consider the negative. I just want to know the distance, and I'm thinking about my picture. So it is negative. That tells us what direction it's going to open. I'm just going to put the 1/4 there. 4 times 1/4 is 1, so I get 1 here. So that means my focus is going to be on the inside, and it's going to be to the left 1. My directrix is going to be over here on the right side, and it's going to be to the right 1. So, Lennon, what would the coordinates of the focus be for this one? If you start at the vertex right here, you're at 3, 0. You need to go to the left 1. Which coordinate is that going to change? X. So if we go from 3, 0, what are we going to have over here? Go left 1. 2, 0. Yeah. And then our directrix, that is going to be at 4, but it's a line instead of a point. So we're going to call it x equals 4. And then, Connor, what's the axis of symmetry for that? It needs to be either x equals or y equals. It is a horizontal line, so that is a y equals 0. Yeah. Yeah. For the directrix and the axis of symmetry, those are lines, so you need to have x equals a number or y equals a number for those. The vertex and the focus are points, so you'll have 2 coordinates for those. Okay, questions? All right, we're not going to do these x and y intercepts. I want us to do this problem. No. So I want us to skip this problem and do... I'm trying to think if there's anything remarkable about this problem that you might. So there is no x squared, but there is a y squared. So that lets us know that this would be a parabola. So for parabolas, one of the variables will be squared, but the other variable will not be. If both of the, like if you have an x squared and a y squared, it makes it a circle, an ellipse, or a hyperbola. So it's one of those other 3 that we were talking about if they're both squared. So a parabola is pretty easy. Like if I gave you a problem like we had on the warm-up, a parabola is pretty easy to spot because only one of them would be squared for that. I don't think I want to do this one either. Let me see if I put... Okay. I want to do one of these from your assignment. So if you want to just get a sheet of paper, this will be from your assignment, so you'll have one of them done. And let's see. I want to do number 16. So you guys are going to do 13 through 21 here. We're going to do 16. If yours are out of order, that's fine. And let's see, we got y squared plus 12x. Y squared plus 12x equals 2y minus 13. Okay, so first of all, we need to think about what variable needs to be, which variable needs to be solved for, the x or for the y. Which one is it going to be here? The x, okay? So we need to get that x by itself. We're going to move the y over to the other side. So we'll have 12x equals negative y squared plus 2y minus 13. Now, here's the trouble with this. To solve this for x, that means I need to divide everything by 12. Does 12 go into anything on the right-hand side? Nothing, right? It doesn't go evenly with anything. So we could go ahead and divide by 12, and then we would have to complete the square using fractions, which is possible but not desirable. So the other option that we have on this one is to hold off on the 12. Leave it there, and we're going to deal with it at the end. And that is going to be a little bit easier to deal with. So we're just going to leave this like it is, and we're going to complete the square over here on the right-hand side. So I do have that negative right there. I want to factor that out. So I've got that negative 1 times y squared minus 2y plus blank minus 13 minus blank. So if I complete the square, I'll have y minus 1 squared, and then I'll put a 1 here. And then what number do I subtract over here? Negative 1. So I'm subtracting negative 1, which is actually like adding positive 1, right? So I end up with negative 12 right here. Okay, everybody okay here? Then you can divide by 12. So you got to divide each term by 12. All of this stuff right here is a term because it's all multiplied together. All of this stuff and the 12 is a term, right? So we're going to divide by 12. We'll divide this by 12, and we'll divide this by 12. So what happens for this is we'll have negative 1/12 times y minus 1 squared minus 1. So if you wait on that 12 to the very end, it is easier to deal with than if you do it at the beginning, because you're going to have like 1/12 and you're going to be trying to factor that out, complete the square. It'll just be a little bit easier to do it this way. Everybody okay here? All right. Let's see. Lee, what is the, not center, what's the vertex of that? Negative 1, 1. Perfect. Kendall, which direction does it open? Up, down, left, right? Almost. You're, at least, it's going to be left. You picked one of the, at least left or right, which is correct. X equals tells you left or right. Then you're going to look at this number right here, your A value. If it is negative, it's going to be to the left. If that number is positive, it'll open to the right. Okay? So this one is going to open to the left. We've got the point negative 1, 1 as our vertex. So the focus will be here on the inside. The directrix is over here on the outside. We're going to do P equals 1 over 4 times A. Again, I just ignore the sign because it's a length, so it doesn't really matter that much which sign it is. So this one's a little trickier. 4 times 1/12 is going to be 4/12, which reduces to 1/3. And then dividing fractions is easy as pie. Flip the second, multiply, you'll get 3 for that. So your focal length right here is 3. So Troy, for this one, our vertex is at negative 1, 1. Our focus is over here to the left of that. What are the coordinates of our focus going to be? Yes, good. Because we are moving to the left, which is going to change our x coordinate. Since we're going left, we've got to subtract 3, which will give us a negative 4. Very good. Let's see, linen, directrix is over here. It's a vertical line. It's going to be x equals, what number will we get there? 2. Perfect. So you're at negative 1. You got to go to the right 3 units. What's that sign? Oh.
Yeah, I don't know. The water.
Where?
Are they like in the gutters or something? Coach Road.
Oh, they are. They're probably in the gutters up there. Yeah, it's a water hose. It's not Coach Wood this time. It has been Coach Wood before. One time it was somebody working on the roof, and they were very young looking, and I thought it was a student out on the roof, and I fussed at them to get off of the roof, and then looked down and saw like another worker that was clearly like an older person, and realized that it wasn't a student. But were you in here whenever Coach Wood knocked on the window with his headset on? I think that might have been pre-cal last year. He came down here with his like headset on, like he uses in football to call plays and stuff. He came down here, knocked on the window, pressed his face up against the glass, said Ricky Bobby was his best friend, and then went back to his classroom. Yeah. He walked along. Yeah, he just went out of his room, walked over here. Yeah. And interrupted my class from the window.
For half of like last year, he just would wander off.
He wanders.
He'd just be doing IXL and he'd just go somewhere else.
Yeah.
Okay, my Excel, you got it wrong. You just kind of let just kind of walk out.
Yeah.
That don't feel like so.
It was like the last month of class, and it was,
Yeah.
it was Coach Norman and Coach Wood sitting there, and me and Marshall talking, and I said, I play football next year, can I get an A?
Did he agree?
Yeah, and then I played football.
Yeah.
Did you get an A?
No.
He knew you weren't going to do it. All right. And then axis of symmetry on this one will be y equals 1. So it'll be a horizontal line. We good here? Okay. As good as we're going to be. All right. So, parabolas seem like they should be the easiest. I think they're the most difficult of the 4 types because the other 3 types are all really similar to each other, and you do the same stuff. The parabolas are a little bit different, but not impossible either. I think you guys can do it. So you guys have the assignment. You guys can work. I'll be around to help. You can also ask Jack a question if he's around, if he's still here. He's an expert, one of my star students.